Hi everyone. So before we go ahead, as you can see on the screen, since this will be recorded and posted on YouTube, if you want, you could use the chat box to ask your questions. And yeah, let's get started. So hi everyone, I'm Prerona, and on behalf of LLVM Social Bangalore, we welcome you to the first session of this online series, Introduction to Common Compiler Tools. This series is this session and all the other sessions are going to be 1 hour long from 6:30 p.m. to 7:30 p.m. IST. And we have a total of around 10 sessions, which means that starting this Saturday, for the next 10 Saturdays, we hope to meet you here. Before we go further, I would like to briefly mention about LLVM Social Bangalore. So this meetup was started by Aditya Kumar and Rishabh Sharma in 2019 with the aim of building a strong compiler community in India. And we organize meetups almost every month. In fact, the last session that we had was conducted by, can you please mute yourself, whoever it is? Thanks. So yes, I was saying that we welcome people from both academia and industry to share whatever they are working on and enlighten the audience. So last meetup that was online, and it was conducted by, it was given by Professor Rupesh Nasre from IIT Madras, and it was on parallel graph algorithm generation. So by the name, you might have understood that these sessions kind of required you to have an involved understanding of compiler technology. But this session, which you are currently a part of, is intended to be lightweight. In fact, those who are not working on compilers also can benefit from this session. In fact, any software developer will benefit from this session, which which we will get to understand in the coming slides. I think that's the reason why we have around 1280 plus members as of today, and it's a great number if you see. So uh, we are glad to share that we have Aditya and Rishabh, who are the founders of the meetup, in this session as well. And we also have the organizers, Pradeep, Ashutosh, along with us. So I'd pause for a minute and see if you would like to add anything. Rishabh, Aditya, Ashutosh, Pradeep.
I'll um, I'll take a few seconds. Firstly, I'm
Till
like super.
then, yeah.
Yeah,
Yes.
it's yeah. Let's show the pictures. The only thing is, just want to reiterate this series of classes are mostly for people who are um, they are introduced to computer science, or they are working on like some field of IT, but they may not have like any experience with compilers, and that is totally fine. That is the whole point of these meetups. We want to introduce you to things, and as we see make progress, you will see the agenda of the next 10 classes. So do not get discouraged or something that compiler is a very niche field. It is, but there are many things which everyone can use and benefit. So each lecture will be individual. At the end of the one lecture, you will benefit definitely from each lecture separately. So it's not like a TV series that you have to start from episode 1. You can join at any time. You'll definitely benefit. That is how we have designed this.
Uh, Amazing. I mean, yeah, you have perfectly put out the things. And yeah, these are two of the pictures from our recent meetups. I think the previous one was the picture taken at the first meetup, and this one is a recent one. Um, yeah, so I can get to the next slide then. So yeah, the presenters for this lecture series are the four of us: Aditya, Ashutosh, Pradeep, and myself, Prerona. And today we have, apart from us, we have Rishabh and Samiran. So this session is basically an AMA, which means that you can ask your questions related to the compiler domain to all of us. And I think it would be better if we just create a background for you so that we are in a better position to ask questions and make the best use of it. So um, I have told about, I mean, I've mentioned compilers a lot of time. Even in the posters, you would see the compiler terms a lot of time. So what are compilers? I mean, let's have any answers from the audience. Someone would like to share anything? We would like to this to be an interactive session as well. So anyone would like to mention what's a compiler?
It's basically a way to like convert the code from a human code to a machine code.
Right, on spot. So yeah, in brief, you could say this, but the compiler does a lot more than that, which is for sure a separate session. In fact, it should be separate multiple sessions. But yes, I could mention one more point here that when you're converting from a source program, which is a high-level language, to a target program, which could be a low-level language also, or it could be another high-level language. Um, you also the compiler also does check for programming errors, and it tries to optimize the code for speed and code size. So would you like would Pradeep and Ashutosh would like to add anything? Maybe if they can add here. So now that we have a brief understanding of what is a compiler, you do have an opportunity to check out the open source compilers, LLVM and GCC, compiler infrastructures, LLVM and GCC, which are used by a lot of industries as well as it's used in the academia for research purposes. So I would request Ashutosh to brief us more about LLVM and GCC.
Yeah. So a lot of compiler development is primarily driven by fields such as HPC, and some of the most popular languages in this area are C, C++, and Fortran. I know people are surprised by seeing Fortran up there, but yes, there's still a lot of stuff written in Fortran. So two of the major open source compilers whose code is publicly available are Clang LLVM and GCC. So there are also a lot of proprietary compilers. So their code is not open source, but you can download them and use them. So such as the Intel compiler collection, the AMD optimizing C, C++ compiler, PGI compiler, the Cray compiler, and ARMS compiler. So what is the difference and why are there even multiple compilers, for a single language? So one way you can think of this is that the people that define the standard from the language for the language, like say what goes into C++23 or C++26, they are different people from the people that write the compiler. So it's always good to have more than one compiler because you have a single point of failure in case something is not implemented well. There are some things that LLVM does better than GCC and vice versa. So LLVM is a term that you'll see a lot in this meeting and next few meetings. So it used to stand for low-level virtual machine, but now it doesn't stand for anything. It's an outdated acronym. So it's a modular set of compiler and toolchain technologies. So you can think of it as building blocks that you can use to build a compiler, and not only a compiler, but other tools also like static analysis tools, linters, code completion tools, code formatting tools, and a lot of other kind of tools that we'll be covering in the future sessions. So that's there. And so these are like some of the tools that you can see, right? Clang tidy, clang format, and LLDB. So we'll be going through them. While GCC is the GNU C plus plus compiler or the GNU compiler collection. So the main reason LLVM was started was one was licensing reasons. LLVM allows you to take its source code and add proprietary extensions and not make those proprietary extensions public, while GCC is released under the GPL license that sort of forbids you from making those changes unless you open source those changes. But now we have these two major open source compilers, and GCC is still the standard compiler shipped with most Linux distributions. So if you download Ubuntu or Debian or any other Linux distro, chances are it will come with GCC pre-installed. So that's a little bit about compilers. Now, Prerna will tell you about the sessions planned ahead.
Thanks. I mean, you had covered about linters and Clang format. So, for example, a very basic example, I would say you are writing a C++ code and you forgot to do the indentation. Instead of doing it manually, you would like to have a tool which does this automatically for you. So, Clang format, for example, does this. Similarly, if you want to as a software developer, as a new software developer, you might have to work on a code which is where so many people are contributing, which means it's a large code base. It would be a large code base, I would assume. So there, if you're assigned a bug to fix, or if you, run into an issue, how to debug it efficiently. So for that, you could use LLDB and GDB. Or if you want to, use the compiler to generate uh, uh, to maximize the performance and the code size of your input, to maximize the performance and reduce the code size of your input program, then what compiler flags you could use. This is also very important thing, I believe, for any software developer. So in all, if you look at the contents of this session, it will help you be more aware about what all tools you can use from the compiler framework, and make your life much more easier, and yes, be more efficient. So the second session, which will be on the next Saturday, would be around technologies enabled by LLVM. And I think it would be an interesting session to attend, because you will get to know, you'll come across many known technologies which are enabled by LLVM. This it will, encourage you to learn more about this domain, the compiler industry in general. So I think we can go to the next slide now. Do you want to, do any one of us want to add anything? Okay, so let me go to the next slide. So yes, uh, this is basically a slide. Uh, uh, I assume that many of us would be straight out of our BTech courses. Basically, we have experience in knowing what all computer. Um, Basically, we have learned. We have done engineering in computer science. So it might be interesting to know how various other subjects of computer science get used in the compiler domain. So compiler is a subset of computer science, but the other subjects like, say, discrete mathematics, um, data structures, design and analysis of algorithms, how are these involved in the compiler domain is interesting to see. But what I'm going to present further is not at all an exhaustive list, because this is again going to be a separate session if we have to cover it. But the main aim behind putting this table was to share this information, that if you are a compiler engineer, compiler developer, there are chances that you might have to understand not only the input program, the high level program, but also understand the underlying architecture, so that you can do better optimizations. And so that's where your computer architecture is getting used. Maybe I can take an example. Instead of going through this table, I can take an example. So there is some there's a data flow analysis, liveness analysis, which basically evaluates at a given program point what all variables are live. So what it does is it takes converts. So your input program is converted into a control flow graph, and you traverse through it through bottom up, which means that you do a reverse post order traversal of the graph which is constructed, and at each program point you try to determine what variables are live and what variables are killed. So I would like to highlight here that all this analysis, this liveness analysis, is actually a set of linear equations. And whenever you're implementing in the commercial compilers, you also need to take care of the time complexity, the space complexity of these optimizations. So you may see, you can see that in this small example that I've covered from a very high level, so many concepts are getting used, like discrete mathematics has been used, data structures, C++ concepts, and you also evaluate the time complexity. So the main aim behind this is that when you're starting out new in this field and you're trying to understand any compiler concept, which is completely new, there are high chances that you would come across some terms which you have already known earlier. So personally, for me, it has helped me build confidence and connect the dots better. Maybe I would request Pradeep to share if he wants to add anything here.
Yeah, thanks, Prerna. I guess the main core of most compilers is graph theory, because a lot of fundamental algorithms that compilers use are based on graph algorithms. The program representation that high-level languages use is an AST, which is it's a tree, and it also has cycles, but that's a catch there. And there are the intermediate representations that most compilers use are based on control flow graphs, which are directed graphs. And at every stage of compiler, you can see different kinds of graph algorithms being used. For example, in scheduling, you use DAGs. In register allocation, you use graph coloring to allocate each variable to its registers. And for there are we use minimum spanning trees to instrument the program and analyze for code coverage and detect any bugs. So graph theory is one of the fundamental concepts that you need to understand to understand the area of compilers. It's definitely going to be on the interview list for sure. And apart from that, you need most of the compilers are written in C++. I can see that some of you asked questions about what is the language. So most compilers are written in C++, but that's not always the case. For example, the Go compiler is written in Go, and most of the Rust compiler is written in Rust, though it also compiles down to LLVM and has an interface through Rust. So it doesn't mean that I mean, in order to get started, I would say knowing C++ would be a good thing to know. And apart from that, compilers, you don't have to know about the computer architecture for most cases. Uh, because there are compilers that translate from high-level language to a high-level language. You don't have to know about the computer architecture. So it depends on what you will be working on, because compilers have a lot more levels. There are people who just work on the front end, who just know about the high-level language, not know about the architecture. But there are people who work close with the hardware, that they have to know each corner of it. So just take with a grain of salt that you don't have to know all of it, but it's good to know. I mean, depending on which application that you're working on, that you're comfortable with. Yeah, I think that's it.
Thanks.
Yeah.
Yeah. So yes, again, I would like to highlight that it's if you are a new compiler engineer, completely new to the field, you would be always able to correlate whatever you are learning to your engineering course. So that has been the case for me, and yeah, that has been one of the motivating factors in learning something new in the compiler domain. So this table is left to the audience to read and ask questions if any later. So we can go to the next slide. Okay, so now that we know how the compiler domain is using so many concepts from the computer science, other subjects of computer science, we would be also interested in knowing what a compiler engineer actually does. You would say that all these compilers, GCC, Clang, are already there. So what new are we doing? Well, we work on a lot of things. I'll share my bit of things and open the forum for others to speak. So yes, this slide actually beautifully divides it into 4 parts. So optimizations is sounds very interesting to a compiler developer, and what we mainly do is we try to extract the maximum performance from the system. And yes, so we see various examples here like vectorization, loop unrolling, inlining, and etc. We also have to implement new features. So um, in C++ also there are new features added which need to be implemented. Sometimes the underlying architecture also adds new features that we need to support. So like any architecture might, with a new architecture, you might have new assembly instructions which need to be supported by the compiler because they help in a better performance. And I must highlight one thing here. Any compiler, any code you write for the compiler, that needs to be thoroughly tested. You cannot break the uh, existing test cases, neither you can reduce the performance of the existing test cases. Apart from that, you also need to add test cases for the code that you have written. So I'll pause here and I'll let the other members of the panel speak.
So
Yeah.
do you want to take it? Oh, sorry, Adya. Yeah.
Go ahead. Like, I guess one person can start and like talk about like what you're doing on a day-to-day.
Sure. I'm Pradeep. I work as a GPU compiler engineer at NVIDIA. So most of my work is dealing with performance optimizations, there are different applications that we compile for, and each application has its own performance characteristics. And whenever there's a corner case where we can generate more better code, we take a look at this case and see if we can teach the compiler to optimize that case. So that's most of my work, and I also work in the front end where we implement the OpenCL programming language. So OpenCL programming language has its own it's a dialect of C, and if are any features that um, that that we need to implement and make a compiler recognize and optimize, we start adding the features in the front end and lower it to the middle end to do further optimizations. Yeah.
Okay, I can also share what I work on. Sorry, I'm not able to see people, so maybe I'm just interrupting anyone. If that's the case, please do let me know. So I work with NVIDIA as a GPU compiler engineer. I can highlight one thing which I had worked on. So it was GPU has something called as constant banks. So I had got a chance to implement support for constant banks, reading from constant banks in in the compiler in a new infrastructure. So yeah, that's one thing I would like to highlight about.
I can go ahead now. So I started initially as someone who was trying to do some verification in the compilers to verify if the things are correct, if there are any bugs in the compiler. So until I started with that, I only knew that a compiler gives some error. So I wasn't aware that there can be even bugs in the compiler itself. So I started initially working on that. So figure out and try to test the compiler and see if it has some bugs. So that's something initially which converted later into, okay, where are these bugs coming from and what are the optimizations. So I worked in AMD in the past. So while working there, I even started figuring out some new languages and adding support for them in compilers. That was Fortran. And let's say you started adding all of this support for a language, then the next part comes is the compiler optimization. So mostly you work on figuring out like where are the bottlenecks, and then you go and then try to see the profilers or the tools which help you to analyze where the bottlenecks are coming from. So then I even worked on a few profiling. Let's say someone, oh yeah, there is this bolt. So worked on these profiling tools which help you analyze where the bottlenecks are coming from. And I used to like tell the developers, hey, this is where the issue is in this particular benchmark or in this particular code. So seeing that, they would, okay, this is the problem and let's see how to solve it. And they used to write some optimizations on that. So that's something was my area of work in the industry space. Coming into the research, currently I work on mostly solving the bottlenecks in compilers from a research perspective of figuring out the data movement and data layout, which is how the data is laid in the memory. And after the Moore's law, it's the computation. People have been optimizing computation for a long, and that's seeing a bottleneck at some point, and it's bottleneck mostly by the memory. And it's the current scenario in the whole architecture space as well as applications. They need this memory to be solved, the memory bottleneck to be solved through compilers and all. So the current area is finding and optimizing this memory related stuff. Let's say how the data is laid in the memory, how do you move the data, and that's what. So mostly, let's say, seeing all the deep learning and neural networks architectures, end-to-end models. So we try to see how we can optimize them through the memory hierarchies, and how you can use, let's say, some architecture, let's say recent architectures, like we try to use GPUs to offload stuff. Maybe, let's say, sometimes we try to see the TPU or some accelerator. So that's some of the area of my work.
Thanks, Amirin. Thanks a lot. We are glad to know about your research work and as well as your journey in the industry. Anyone wants to go ahead, or we could go to the next slide?
Rishabh, tell us about
Yes.
like what you're doing. Okay.
Hey, you're muted, man.
Hello, am I audible?
Yeah.
Yeah, so basically currently I am working on a Clang plugin which performs automatic differentiation. And in the past, I have accelerated morphological operations using MLIR. So that's my experience currently with compilers.
Nice.
I
Very
would
heavy
like to
weighted
add-
words.
Sorry.
Yeah. I would suggest, like, people who are in the audience, just want to let you know, like, both Rishabh and Samiran, they are doing PhD. So, like, they are like sometimes, like, they are using term which you might not have heard before. They are like doing on cutting edge research. So these are fancy things. So mostly what you need is, if you are so very interested in compilers, let's say you worked on compiler for like a year or two, and then you want to know, like, you want to just like kind of see like what can be done, like what will be done in the next few years, and like you have some ideas, you are going to be interested in like really cutting edge stuff. So there are many professors in US, in other parts of the world, India also, that they would gladly take you as a PhD candidate. And you'll be surprised to know that many of the professors who work on compiler, they always have openings and less students. Okay, so if you have strong interest there, you have contributed a little bit to the open source community, you can personally reach out to them, and then then it depends on both you and the professor, like how it goes, but it'll be a very nice experience if you want to pursue further. I'll take one more minute to describe like what many other people do in the compiler as a compiler engineer on a daily basis. So the compiler itself is not only like code generation, like taking C++ program to assembly code. These days compiler tools have evolved to many different dimensions. One dimension is optimization, what we mostly talk about as compiler engineer, like optimizing code from source language to target language, and then optimizing for performance or code size. But this is like one part that is a traditional compiler engineering. And there are like many other domains that have evolved. For example, analyzing code for security. So finding bugs in the program. So sanitization. Finding bugs is like really important. All the security vulnerabilities you have. There are ways where compiler can be uh, used to find security vulnerabilities. You can instrument the program. Instrumenting means compiler will automatically insert certain code in your code itself, and then when you run the program, it will check for certain things and it will find bugs in your program. It can crash the program if there is a problem. So those like very advanced things are possible, but you don't have to know those things to use them. You can use them directly even today. That's the fun part, right? You don't have to know like really crazy parts about that. Like if you have worked on multi-threading, there it is very hard to find data races. But there is a tool, for example, called thread sanitizer. It will find bug as if like magic. Okay, and you have to know nothing about it. The theory of thread sanitizer, like the theory, if you go and read about the theory, it is so advanced. It's like it's as much as theory of relativity. Like it goes into physics and how time travel. It's not sorry time travel. How time itself is perceived across different reference points. But you have to know nothing about it. You just add a flag and you'll find bug for you. It's just that much powerful, and people work on that part on a daily basis. There are like many things that they do. I personally work on optimization. Like I guess there are many other people who work on optimization here, and optimization is very fun part. Uh, One last thing I wanted to mention is what keeps you going. Like let's say you work on compilers. Most of the job, if you work for like 5 years or something, what happens is you probably know the domain and it starts getting boring. Like what is next for you? The nice part about compiler is once you work on something, that part is done like almost forever. So there is always new things coming up. Okay, so that is one part that keeps you going. The second part is the impact itself is crazy high. Like imagine every computer in this world would have some form of compiler. Every computer will have some form of library, like C++ library, C library. So even if you make the tiniest optimization that is possible, let's say you make a very small optimization that reduces one instruction. Okay, one instruction is so small, right? But every computer will be executing that instructions millions and billions of times per day, and then there are billions of computers. So your one optimization can have like a crazy amount of impact. So you'll feel like really proud. You'll have a lot of bragging rights once you are working on things. And almost all of us here would have done something that they would tell their like next generation that I did something that has like a big impact here. All right, I guess enough of brand. So you guys can move to the next slide.
I would add 3 points. Like it's a famous acronym in this whole space that there are 3 P's in compilers, which is performance, programmability, and productivity. So this is one of the area. This is what people try to do. Like they try to increase the performance either. Now there can be lots of ways to do that. They try to do the programmability, which is, let's say there are new hardwares. How do you program them? How can we use them? That's programmability. And then comes the productivity, which is the people who write the let's say the code, how it can be productive for them. Let's say for not writing the assembly, they would write in some high level like Python, and it should give the same performance and stuff. So it's a very short acronym.
Wow, I mean, yes, all of you have, this was my realization, but you have beautifully put it into words. So it's indeed a great field, a great domain to be a part of. And you do feel happy when you are doing work which is impacting a lot of people. So yes, maybe Ashutosh would like to take over the slide.
Yeah, so again, coming to an important thing, what are the organizations that are developing compilers or offering jobs? So you can see there's a github.io link there. That's a page that lists all compiler jobs across the world, and there are a lot of them. And also, yes, while it is true that the number of compiler openings is less than, say, generic development, it's also true that the number of applicants is a lot lesser than as well. Most of these positions are very well compensated for. So in the companies, you have companies like AMD, Intel, Nvidia, Apple, Qualcomm, ARM. These are all semiconductor companies. So anyone who makes them chip, they make compilers for those chips. There's also Google and Microsoft. Microsoft's been maintaining MSP for a very long time. Google created the MLIR project. So these are some of the major companies. There are a lot more. Uh, there's also a research aspect where there's a lot of national and international labs. This is the LANL, Los Alamos National Laboratory, BNL, which is Brookhaven National Laboratory. There's CERN in IIT Madras. There's the PACE lab. IIT Hyderabad also has a compiler lab, I believe. So these are all places. There are several new Indian startups also, such as Polymer, also work on compilers. So these pursue more researchy topics. And then, of course, there's a lot of open source projects. Virtually every programming language, with a few exceptions, such as MATLAB, has an open source compiler. You have GCC, you have LLVM, you have GraalVM, which is Oracle's new framework for writing language. There's also some effort into developing specialized languages for quantum computers that includes Qiskit and F Sharp. So there's a lot of organizations working on developing compilers. And, a lot of them work on very different problems. I work in a CPU compiler team, and the folks who work on the GPU side do totally different stuff. So there's a lot of scope. A lot of them use LLVM. Some of them don't use LLVM. Some of them use GCC. So you can have your pick. So that's it.
Yes, thank you. Maybe now we can highlight a bit more on what is what is there to be solved in compilers and the areas of research. So, Pradeep, you would like to take over?
Yeah, thanks, Prerna. Yeah, so I'd like to. So this is not an exhaustive list again. So this is something that came to my mind. And so, for example, phase ordering is where you have different compiler optimizations, and you want to find the perfect order of optimization that you want to apply. So each transform a code in a different way, and you have to find the right set of ways that works for your hardware or any sort of configuration that you're optimizing for. And second is optimizing automatic parallelization. So given a serial code, how you want to parallelize code for any parallel hardware like GPUs, distributed systems. Though it looks easy, but this has been a area of research for a really long time. And program synthesis, how you want to generate code for a given set of constraints. So if you're very much into data science, then you have machine learning and deep learning being applied into compiler optimizations. So most of the compiler optimizations that are there right now take a heuristic. For example, if you want to inline a piece of code, how much do you want to inline? Because there are cases where you code size can increase enormously, that you might see a decrease in performance. So these are hand tuned by compiler engineers based on benchmarks, based on the real code that they see. But since they're mostly a data-driven problem, they can be offloaded to machine learning models or deep learning models. So currently, with the advent of deep learning and democratization of AI, machine learning and deep learning are being applied to compile optimizations as we speak. And automatic compiler verification. So compiler is as any code have bugs. So there are cases where compilers can generate wrong code, and which might result in security vulnerabilities, segmentation faults, any random errors. So you want to make sure that the compiler itself generates right code and make sure that it's working as expected. So there are formal methods that are being applied to verify the compiler optimizations, and some part of program synthesis also comes in here. And towards the end, there's polyheader optimizations. I guess, Aditya, would you like to speak about this?
Yeah, I guess Samiran already talked a little bit about it, but I'll give like a very general overview so that people who have no idea what this complicated word is, they'll understand a little bit. So polyhedral compiler, it's one branch of compiler technology that deals with like it deals with compiler optimization in a very mathematical way. So I'm very sure all of you here would have solved linear equation in your before class 10th, right? Like linear equation in 2 variables, like linear equation in 4 variables. It's exactly the same, that polyhedral optimization. Of course, when you study polyhedral optimization, it will be slightly more complicated, but the underlying equations that you will see, it will be exactly the same. Few matrix multiplications you will see. But that same mathematical concept can be used to do optimization that will just blow everyone's mind. And we should be like really proud to say that we have professor in ISC Bangalore. His name is Uday. He is like the leading contributor to polyhedral compiler technology. He has been working on that for over a decade, or maybe almost 2 decades now. And I would encourage you to like see what his presentations, and he will show the numbers that you cannot believe. Like some of the code improves by 10x or 20x. And recently they started working on optimizing machine learning frameworks, and his numbers are just mind blowing. Why? Because they have their optimization has solid, let's say, mathematical background. So when it works really amazing. Yeah, I would not go into details because that is not the goal here of the presentation.
Okay, then we can probably go to the next slide, or what? So we can go to the next slide, right? Maybe that would be better. I think in interest of time, since this is more of an AMA session, I would actually skip this slide because a lot of it has already been covered in the previous slides. So if you have any questions, you could ask us later for sure. So this is kind of the last slides, and we can open up for questions, or yeah, we can just have a brief overview of this, and then we can get started with the questions. Or
Yeah, sure, Brana. I guess if so, most of these compiler infrastructures are open source. So like Samiran mentioned in the chat, the way to get started is start working on real world open source compiler problems. So I guess I've mentioned 2 of them here. LLVM has a very good getting started page, and they are very welcoming community. You can find the best way to start is look at the good first issues in the LLVM GitHub page, and look for issues that you think you're interested. And then you can approach the person who you can do a git blame on the file that where the issue is mentioned, and you can find the person who's maintaining it and reach out to him on the next steps. LLVM also has a very good contributing guide where you can look into see how you can what are the steps that are required to land a change in LLVM. And they also have a discourse page where you can post questions, and it's very active that you get your questions answered in a matter of days. And GC also has a very welcoming community. You can find the contributing guide there. GCC also has a mailing list where you can mail and ask questions. And I think apart from that, there are it's not just restricted to LLVM and GCC. There's Rust, Go, and there are lots of compilers that are developed in the open where people can join and contribute. You just have to get started. Yeah, I think that's all I had.
Okay, so we would request you to stay till the end of the session, because by the end we are also planning to share link to a WhatsApp group or so where you could ask your questions and you could connect with us regarding your questions about this session. Am I right, Pradeep and Ashutosh?
Yeah.
Yeah.
Okay, so should we so questions are welcome. you could unmute yourself and ask questions, or if anyone if wants to share their experience, it's also yeah.
Yeah, I think we answered
Yeah.
some questions in the chat, but I think some are left. So if your question got skipped, please ask it now.
Yeah, I have a question. Like I have done BCA, but like I haven't read about compilers in BTech or not. So how can we get started based on that? Like, can you suggest some books or a reading material where can I get started?
I can take if anyone is. Samira, do you want to take up? Then go ahead.
Find a mentor, I would say. If I were to see in my whole past, I got people. So it was really funny how I started. I met someone in a Linux kernel meetup, and I was just excited. He was doing something fun. I saw like, oh, this is good. So I started and I found a mentor. So he was a GCC mentor and a Linux kernel mentor. But get a mentor and you're good to go. That's the easiest
So
way. I
if
think you are good.
anyone is interested here, please let me know.
So a good place is to go on the web page. Let's say I know an LLVM, GCC. I haven't checked in a while, but you would see list of projects and mentors to that. That's something you could just go and talk to, because these people are willing to do something. They are willing to give time, as well as they have some idea and something in the back of their mind which they want to solve. So
Okay.
that's one of the good places to start. That's the most best place, I would say.
Yeah.
Yeah.
So thank you.
Yeah. So it seems like there are audience which like we can bucket into two categories. Let's say first audience is people who have done BTech, so they would have at least taken one course on compiler, so they have some idea. And one part is people who have not taken compiler like at all, right? Like BCA or maybe some other degree. Maybe their university did not have course on compiler. They would have done other computer science courses, right? So for these two sets, I guess the approach would be different. People who have taken at least one course on compiler, they would have some lead, right? Like they know what to search for. At least that is what the part they are done. They can Google what is compiler, what is LLVM, and they will have a slightly better understanding of how to navigate this whole situation. People who have like absolutely no idea about compiler, like they have never taken a course on compiler, I would suggest that spend a little bit of time, like go to Coursera. Coursera has course from Stanford University. It's all free. Okay, you don't have to pay like a single rupees. So even on YouTube there will be some course series. So what you do is get a general understanding of compilers. Okay, what compiler does, like at least major components like parsing, code generation, etc. So if you take any online course, it will take like less than 30 days or 2 months, and you will have at least good understanding of how to start searching for it, right? There are many people who are going to help you, but if you just directly show up and you say I want to work on it, but then they will talk to you, right? Like what do you know? So you must have at least some understanding that okay, whatever I'm talking you are actually understanding. So for that, I guess you should at least spend some time, do homework, and then come there. That will have you will have a better outcome. Otherwise, if you get rejection or something and then you feel bad, it's not good thing. So you do some little bit of
Okay.
homework there. Okay.
I would like to add one thing here. So I started out as an intern with NVIDIA, but even before that, I had got a chance to attend ACM Summer Compiler School. So that happens in, I'm not sure if it happens, but last to last year also it happened. So there they cover a lot of topics which are little advanced, but they will, I mean, you will be able to understand a lot from it. So you don't need to really have a lot of understanding about compilers, because the professors, whoever is teaching there, they beautifully teach you from scratch. So ACM's ACM summer schools are also a good platform, or a way where you can get started with compilers.
One more way is
Can we
through
do that?
Google Summer of Code. So GSOC has a lot of programming and compiler specific organizations such as GCC and LLVM participating. So a lot of the folks I know are former GSOC participants, or they're people who submitted proposals to GSOC, and during that they learned. So if you go through GSOC page of LLVM, it has very, very beginner friendly projects. They all assume that you know nothing about compilers and you're coming from outside and you have like 3 months to implement a project. So Google Summer of Code and now even the Linux Foundation mentorship program, they host mentorships related to LLVM and GCC and Julia, Rust, Haskell. All of these orgs participate there. So that is again a great way to get engaged.
Okay.
I think Rahul also mentioned the SIG Plan M mentoring program. I guess Rishabh or Rahul, can you please talk to that? Hey Rishabh, I think you're muted.
Yeah. If you're interested in research, if you want to pursue research, if you're already doing research, if you want to get into a PhD program, or uh, if you are already working in industry and want to transition into a more research-ish role, then you can apply there. You can get a mentor, and you get a mentor for a year, and then you can kind of renew your mentor if you and your mentor both like the interactions and everything. It has been very helpful for me so far. And they have a form in which they ask you in a very detailed way that what you want from the mentorship program. And even if you feel that you may not fit well in the mentorship program, I'll still recommend that you fill the form and apply, and we will figure out that do we have a mentor which can be a good fit for you.
Okay, so where can I find that form?
I can send you a link. Like someone shared the link, but I can again share the link. It's on the chat. So it's on
Yeah,
the sick plan website. It's called, if you search sick plan long term mentorship, you'll find it. But I also posted it on chat.
yeah. So
Hi,
Rahul,
can
if
you
you
hear
can
me?
unmute. Uh, yeah, I can hear you.
Yeah, can you hear me? Okay, yeah, hi. Hey everyone. But like Rishabh just mentioned about PhDs and research and compilers. My experience with SIGPlan was not at all in that uh like domain actually. I was using it as my it was my first internship in the industry, and my mentor was actually helping me through the industry aspect of it more than the research aspect of it. So yeah, I think even though it's targeted at people who are in academia, I think even if you want to get started with industry, or you want to at least have some baseline knowledge about what this whole compiler or systems or like architecture space is all about, I think even then it would be a good fit to be inside this SIGPlan M.
Yeah, we do have mentors there which are not from academia or even research, but they are still less. That's why I said that like you should fill the form and mention what is your mentorship need, and the ops team will figure out a mentor for you. Or if they feel that you are not a good fit for the program, they'll let you know. But most of the time we try to figure out a mentor.
So basically, is it a full-time program, or like we can do it part-time?
Oh no,
Because like
it's just
currently
that
I'm working.
you and your mentor will decide how often you want to meet. So for example, me and my
Okay,
mentor, we meet once a quarter. So people meet once a month. Yeah.
okay.
Oh, I met once a week, so
Like,
PLDI also has a mentoring group. So um, some folks can also benefit from just volunteering at a conference.
yeah.
What you do is look for conferences which are in the programming language domain, like CTO, PLDI, POPL. There are at least like 7-8 of them. And look for when they're starting, they will ask for volunteers. They help for with operational aspects. So uh, like you help with operational aspect, but you get in touch with so many good compiler engineers. And they also have programs, let's say mentoring program. So I shared one with PLDI. I signed up once for mentoring. So there are students who will talk to you. As a mentor, I was talking to students. They would have like all kinds of questions. Like every person have different set of things that they want to ask, right? Like not everyone can fit in one general framework. So you can ask, you'll have like 30, 45 minutes, and you can ask all kinds of questions there. Just and then you will have more confidence in like going into this program. Okay.
Any other questions?
There was one interesting comment I saw on the chat that is a master's degree required to work in the compiler industry. So the answers have been already given, but yes, we must highlight it again that no, I think the thing which is important is your passion for learning something new. At least for me, that has been the requirement, capable of incorporating the feedbacks, and people are very helpful, as you would have got to know by this session. So people do help you in your journey. You just need to start doing.
Hello, this is Sanskar. I had a small question. So I am in the final year of my BTech program. I took one course as part of my semester subject called Compiler Design, where we learned about parsing, semantic analysis, syntax analyzer, etc., code optimization. So like I know what goes on into the compiler, but like to be able to become a compiler engineer, we have to do the hands-on, right? We have to get well versed like what happens in the industry. So for that, what should be my first step? Like where should I apply this theoretical knowledge?
So you have to realize that the compilers that we work on in the industry are mostly the same or similar code base as the open source ones. So basically, if you know how to contribute to LLVM, if you know how to contribute passes, if you know how to work on optimizations, if you know how to work in the front end, or you know about GCC and sending patches to GCC, you already know a major portion of what you have to do in a job. But yeah, like most jobs are more optimization focused and less front end feature development related. But yes, the open source compilers are very much production quality compilers. So if you contribute to them, if you see their code and you can work through it and submit patches, you're good enough for the industry, at least at the entry level.
Yeah, what Ashutosh mentioned exactly. One more thing is if you are completing your bachelor's and you have taken course, what I would suggest is find the job on compilers and just apply. Okay, like maybe you are already pretty good. Like, so how do you get into company? You have an interview. In interview, they are not asking like you to write compiler optimization or pass. They are asking concepts. And if you already know, you'll get into a job. And first few months you'll learn the whole lot of things already. So don't wait for another year to GSOC or something. Just apply. If you get a job, you'll know everything. And if you don't, then you can also do all these steps. Like let's say you get a job in another company which does not work on compilers, and you're still interested. So look at the open source project, how people are putting up patches, and the best strategy, what Samiran said, find someone who is already working on it. Okay, and then just tag along. That is the best way to learn. Like it's like finding a guru, and that person will help you for your entire journey. Don't worry about, like you can just ask them any questions basically.
Yeah, I totally agree with your point. That is the only reason why I was interested in this webinar from the first, like to get mentorship, to get some support, like guiding, because I was starting from scratch zero. Like I had no idea what goes on into the production, what goes on into the industry standard, just some book knowledge that we studied from the college itself.
Hello, this is Jayashree. I have a question here. Like, I am a final year BTech student here. Suppose if I'm applying to a compiler job in the sense, do I require DSA for the interviews?
That
Yeah,
will depend on the university, I think. Sorry, the company. Some companies may require it.
Yeah, I guess it's most of a standard that
Because, like,
people ask data structures and algorithms question. Yeah, you will get it for sure, but I guess you'll be asked more on the compiler side, and
I guess the question more is like on the requirement side. Like some companies would have strict requirement on a degree, right? So that will depend on the company. Like most of the time, what
But
happens is big companies will have very structured requirement like BTech or BSc or master whatever. But try for a startup, they will have no criteria. All you need to do is like how to code, and you'll be offered a position.
there are a couple of folks in my team who have ECE degrees, but they're working in the compiler team. So if you have the right kind of experience, it's certainly possible.
Is DSA asked in the interviews, like, do we because I see that instead of wasting much more time on that, we can focus on compiler theory, right?
No. So here's one thing. If you ask like 90% of software engineers, they'll say, I have never used quicksort, or I have never used breadth first search in my job. Why did we spend too much time, wasted so much time? That is not true in compilers. On a daily basis, you will be doing breadth first search or depth first search. You must know about it. If you are good, go back and read all the data structure and algorithm. There will be at least one question from there, okay? And there will be more in compilers, but you will definitely, like if I am interviewing a compiler person, if that person does not know depth first search, it's better to not hire them because they'll be in big trouble. So think of like compiler as like playing at the boundary of data structure and algorithm. Okay, it's not like you're we constantly define new structures, we constantly define new algorithms, right? So you have read the book, right? We are kind of writing those things, those are new algorithms. So that is how why it is so much more interesting. I would suggest go and you should read at least those. Like in bachelor, how many algorithms you have? Like 5 of like maybe 6 of them. That's about it. You can learn all of them in like 2-3 days, and then actually write a code. Don't just read and memorize that algorithm. That is not very useful. Try to implement that breadth first search and write a test case and see if whatever you wrote is like even working or not. That's a very good way to do understanding. Understand what goes in the compilers.
Quick update, we've put the link to a WhatsApp group in the chat, so you can use that to follow further meetings in this series as well as reach out to us. So yeah, you can just refer to that.
Okay, so
And one more thing, I'm not actually able to see the chat because I'm viewing through the browser. So can you put the link through mail or something to the WhatsApp group?
Pradeep will put it on the meetup page, maybe. Can we do that?
Actually, on the browser, there's a conversation bubble is there. Maybe you can just click on that and see if it opens it for you, because I'm on the browser also.
If you are not finding, what you can do is, have you used Meetup before? Like in Meetup, there is a message. You can directly message the Meetup organizers. Okay, just message there. We will message you the link directly. Does it make sense?
Oh, okay. Thank you. Yes.
Do you know anyone in the chat group right now? Like anyone?
No, I'm new to this space.
Okay. Just go in the Meetup group. Have you used Meetup before or no?
No, this is my first time as well. I'll figure it out and I'll reach
It's
out
not
if
a big
possible.
deal. You can
Even
figure
by
out
mail.
that part. Just message them and we will message you directly. Okay.
Okay. Thank you.
Hey guys, just a reminder, I think we are almost at the hour. I think we can wrap it up.
Any other questions?
Hey, just one question. Pritish here. Who will finally merge the commits into LLVM repo? Like for Linux kernel, it is the Linus Torvalds who is going to finally merge the commit. Like, is it a one man for LLVM?
It can be even you.
Yeah.
Good luck.
Getting commit access is pretty easy. Like I think they have a document and you just have to email Chris, and they are very lenient in providing commit access.
That is not a big concern also. Don't worry about who. If your patch is approved, you can type there that can someone commit, and someone will commit in a day or two. So don't worry about that too much.
Okay, I was just curious. That's it.
I have a question. So when working with things like LLVM or MLIR, there's a lot of boilerplate code that you have to write in order to get things like the pass manager or like IR generator stuff working. So should I go and read about those in depth or just use them in place? Because as a beginner starting out with these huge code bases, it's like a little difficult to see how the pieces fit together and where the information flows from one part to another. So do you have some tips regarding that?
Yeah.
Thank you.
So I'll share two things. Sorry, because I'm super excited about this part at least. What happens is this happens with many people. Like even as I like 2-3 years ago, I already had several years of experience, but I was contributing to LTO. Now what happens is you have to connect like 20 pieces when something will work. Otherwise, you'll keep getting compiler error or like runtime error. Always there is an error. What you do is there are two technologies, and they are simple technologies where work for every software engineer in the world. The first technology is called git blame. You see that it's on the slide also. So what you do is you go to a file, see what is the interesting part of the code. Let's say one part you say, okay, this is what I will also need. Do a git blame on that Shaki, okay? And that Shaki will give you a patch that is just ready-made. It will work. So that is one technology. And the second technology is called copy paste. Copy paste and start fixing. Like it works for every software engineer in the world, and half of the engineer know copy paste, the other half does not know git blame. Okay, so if once you learn git blame, your life will be amazing.
Yeah, all right, I got it. Thank you.
To add to that, I will probably add my approach. I just instrument the code. So, like compilers themselves have. So you're using compiler to build a compiler. So I'll just use another compiler to instrument the compiler I'm working with and just try to figure out how things are going and how things are working in specific parts of the code.
Yeah, I was more wondering along the lines of how the debugging process might be. Like you just print the stuff that you want to see the changes in, or what do you do with regards to that?
Once you get there, that part, like I guess our target audience here was like very beginner. Once you are that stage where you are debugging, actually ask in the Discord group or somewhere. People will help you pretty. You can just ask them directly.
Okay. Thanks.
If there are no more questions, or do you have
I
any?
have a slightly related but little advanced question on the same topic. So I'm just looking for suggestions or like seeing what others are doing in the space. So like when you have to use LLVM as a library, right? Like do you maintain like dummy boilerplate stubs that you just plug in your new code in and then experiment with it, or like what do you do when you have to use when you have to like just find out what the basically understand the behavior of some APIs in the LLVM library. Like how do you go about it?
I can
I
take
guess,
this one. Oh, go ahead.
yeah, I guess at least from my experience, I usually write a small program just to see what the behavior is. And if that's hard, then you can read through most of the code. It's well documented, and you can see what the expected results are. Yeah, I guess it's more of experimentation, is how I go.
Just to be clear, I'm talking about out of tree usage of the LLVM library, not inside the tree itself.
Oh, yeah. I think it's almost similar way. You can just is that you're linking LLVM instead of compiling LLVM, right? Yeah, I guess it's almost a similar way. It's a library. You can pull any parts of the library and then experiment with it. Yeah.
With regards to like maintaining your own code, yes, if you are have some code on your side, it is you have to maintain it. Nobody else is going to do it. But there are strategies to how to maintain them effectively. If you're just using LLVM as API, then APIs are pretty stable. So they do not break very often, but many companies have they are working on many parts of LLVM. They do not want to share, for example, like say NVIDIA is a classic example. So they have group of engineers who maintain this whole thing, keep up with the upstream. There are many companies who do that. There are many presentations. Search for keeping up with upstream in LLVM. You'll find many presentations. They describe all the problems and all the strategies, what they do to essentially keep up to date with upstream patches.
I think Asutosh or Rishabh can chime in, because I think AMD is one of the compilers that are actively, following the LLVM release.
In our team, I used to say that only the nice people do this maintenance work, because like someone will ask people that can you fix these merge conflict, and people will say, like, people who are nice will say yeah we can, and they just do it. So yeah, I think it's a big overhead. A lot of people and a lot of work hours were invested on this to make it to sync it with the upstream. And I don't think there is a good way out of it, though I have seen a lot of research papers on how to automatically merge your code, but nothing works practically.
Okay. I think we can. It's 7:44 p.m. So I'm glad that we have exceeded the time limit, and maybe we can take any more questions offline.